Alright, so what is a line integral of a vector field? And we might consider that it's kind of like thinking about integrating not over an interval, but over a vector valued function given by r of t that passes through a vector field. The vector field could be two-dimensional or three-dimensional, but this is what it looks like in the three-dimensional case. It would be the line integral over the curve c of f dot dr, which is the same as the force field as a vector field times the t is, remember, the length of r prime. Sorry, it's a unit tangent vector in the length of r prime, so it's r prime of t divided by the length of r prime of t times ds. And so we could actually find that by, now this is a vector field, this is a vector, and when you dot two vectors you get a scalar, so you wind up integrating a scalar function. So here's an example. Find the work done by the force field F on the object moving along the indicated path. Well, the object is moving along the path where C is a line segment from 0, 0, 0 to 5, 3, 2. And the force field is yz times I plus xz times j plus xy times k. Interesting. Well, from Unit 1, Lesson 2, the vector valued function describing C is 5ti plus 3tj plus 2tk. Now think about it. It's 5 minus 0, so 5ti. It's 3 minus 0, so 3tj, and 2 minus 0, so 2tk, with t going from 0 to 1. And of course, this could be different. This could be 5t over 2, 3t over 2, and 2t over 2, t going from 0 to 2, or something like that, but this one will work. Therefore, our r prime is 5i plus 3j plus 2k, and accordingly then we could write our vector function, or sorry, a force field vector, at f of x, y, z, but we're going to replace y with 3t, and we're going to replace z with 2t, and if we multiply it 2t times 3t, we get 6t squared. Similarly, the j component, maybe take a second, figure that out for yourself. It's x times z, so 5t times 2t, so 10t squared, j. And similarly, xy, well, 5t times 3t is 15t squared, k. So when we dot this vector field, or this vector value function, when we dot this vector with r prime, which was here, right? No, sorry, here, there's r prime. So we get 30t squared plus this times 3, 30t squared, and then this times 15 is another 30t squared. The t squared is part of every one of these. So our r prime of t is 90t squared, and so we integrate. The limits of integration are from 0 to 1, as you might guess, based on these values for t. So of 90t squared dt, well, 90t squared is 90t cubed over 3, which is just 30t cubed, and going from 0 to 1, that would be 30 times 1 cubed minus 30 times 0 cubed, so we get 30.